Hello everyone. In this video, we're going to discuss how to identify when to integrate with respect to x or y when we want to find an area. You will have 5 examples, and in each example, we're going to try to set the integral both with respect to x and with respect to y, and then see which one is better. Okay, first example, we have x squared plus 4, which is the red curve, y equals 0, x equals 0, and x equals 2. So if you find the intersection points, for example, here, this point is going to be 2 and 8. You can just plug this point here. So let's first try to set the integral with respect to x. So we're going to consider vertical rectangles this way to cover this area, which is restricted by all the curves there. So as you see, always these rectangles are in a way, and like when you go more, they are always, one side of them is always on the red curve, and the other side of them is on the blue curve, which is the x-axis. So that means we always can say this minus this, the top one minus the one which is below. And when we want to set the integral associated to this area is going to be from 0 to 2, because the rectangles are moving this way, from their x is from 0 to 2, and we have the top which is x squared plus 4 minus the below curve, which is 0 dx. So I'm not going to solve any integral here, I just set the integrals. And now let's try to set the same thing with respect to y. So when we want to set the integral associated to an area with respect to y, we must consider the horizontal rectangle. So now let's consider horizontal rectangles which can cover this area. So as you see, when we get here, the curves which are on two sides of the rectangles are going to change. So as you see in this part, one side of the rectangle is on the green line, the other side is on the purple line. But when we get to this point, which is the y of this point is 4, it's going to change. So now when we consider the rectangles, the horizontal rectangles, one side of them is on the red curve, the other side is on the purple curve. So this means we have to set this, we cannot set this only in one integral. We have to split it into 2 integrals. And something else that we have to consider is that we need everything with respect to y. So for example, when I say this curve minus this curve, I need the equation of this curve with respect to y. That means I need it in the form of x equals some equation of y. So I have to isolate x here, and then I will get x squared equals y minus 4, and then when I solve this I get x equals plus minus square root of y minus 4. And here, of course, the right branch of this is going to be plus y plus square root of 1 minus 4, because the right branch is here x in the right of the y axis, x is positive, so that's why we have to consider plus square root of y minus 4. So now when I set the area here, it's going to be, so first I set from here to here, so y is moving from 0 to 4, or if it's easier for you to think, the rectangles are moving this way, from the horizontal rectangles are moving from 0 to 4 first, and I have the purple line which is 2 minus the green line which is 0 dy plus, or you can find just the area of this rectangle, plus the curve which is on the right, which is the purple one, and it's 2 minus the curve which is on the left, which is x squared plus 4. Sorry, it's going to be here, it should be with respect to y, so this is going to be square root of y minus 4. So I'm going to correct this, plus, so this should be integral, so this integral should be 2 minus square root of y minus 4 dy, and then this should be from 4 up to this point. This point, as I told you, it's 2 and 8, so it's y changing, the y of the rectangle is changing from 4 to 8, or the y is moving from 4 to 8. So here I have 4 to 8. So it's not very hard to set this integral with respect to y, but this is much easier, it's much better, and we don't need to do this extra step. Next example, we have y equals x squared e to the power of x, which is the blue curve. X equals 1 is the green line, y equals 0, the purple x-axis. Okay, so if we want to set the integral with respect to x, first, so I have to consider the vertical rectangles, and as you see, the vertical rectangles are always between 0 and 1, and one side of the rectangles always is on the blue curve, the other side is always on the purple curve. So again, here we can set this area just in one integral, and that's going to be, the rectangles are moving from 0 to 1, and then we have the top curve, which is x squared e to the power of x, minus the below curve, the bottom of the rectangles, which is 0 dx. If you think about solving this integral, you need to wait till you learn integration by parts. It's easy to solve, but you'll need to learn a technique for it. And let's set the integral with respect to y. So now we have to consider horizontal rectangle. So now when we consider the horizontal rectangle, so it's fine, it's going to be a single integral, but the problem here is that we have to isolate x, and it's impossible to isolate x when you have y equals x squared e to the power of x. It's if you think about something, you will not end up with x equals a function of y. So that's why we cannot set the integral in terms of y for this one. And even if you can solve this in terms of y, we might get a very complicated function, which is very hard to find its integral. Next example, we have x equals 4 minus y squared. So as you see, already we have the equation is given in terms of y. So this tells us maybe it's easier to set it in terms of y. And as you see here, when we want to set this with respect to y, it's very easy, because when you consider the horizontal rectangles, one side of them is always on the red curve, the other side is always on the blue curve. So it's very easy, and they are moving from -2 to 2. So that's how the rectangles, or the horizontal rectangles, are moving. So we have -2 to 2, and then we have the curve which is on the right, it's 4 minus y squared, minus the curve on the left, which is x equals 0 dy. So, but if we want to set this with respect to x, still it's possible, but then when you consider the vertical rectangles, you see one side of the rectangle is on the bottom, the top branch of the curve, and the other side of it is on the bottom branch of the curve. So here, if we solve for y, we will get what? We will get y squared equals 4 minus x, and this means y equals plus minus square root of 4 minus x. So the top one is square root of 4 minus x, and the bottom one is minus square root of 4 minus x. So now if we set the integral with respect to x, x is moving from 0 to 4. It's basically how the vertical rectangles which are covering this area are moving. So it's from 0 to 4, and then the top one minus the bottom one, which is going to be square root of 4 minus x, minus square root of 4 minus x, which is going to be plus square root of 4 minus x dx. So as you see, this is not very hard, but this is much easier. So we prefer to set the integral this way. Next one, we have y equals x square and y equals x cube. X square is the black curve here, and the red one is x cube. So it's very, very simple to set it with respect to x. You consider the vertical rectangles, and as you see, you will have integral, and they are moving from 0 to 1. This is the intersection point, which is 1 and 1. So we'll have 0 to 1, then the top one, which is x squared in this curve, because x is between 0 and 1. So I have x squared minus x cubed dx, and that's it. If we want to set it with respect to y, we need an extra step, and that extra step is to turn the equations in terms of y. That means instead of y equals x cubed, we have x equals cube root of y, and then instead of y equals x squared, we'll have x equals plus minus square root of y. And because we are on the right side of the y-axis, x is positive, so we have to consider plus square root of y. So this is x equals square root of y, and this one is x equals cube root of y. And then we consider the horizontal rectangles, which are moving from 0 to 1. And again, one side of the rectangle is on one curve, the other side is on the other curve. There is no change here. So we can set it in just one integral. So it's going to be from 0 to 1. And then we have the right one. The right one is larger because when you are on the right, the numbers on the right are larger than the numbers on the left. So it's going to be cube root of y minus square root of y dy. So again, this is not very hard to set, but this is much easier because you don't need this extra step. And the last example, we have x equals 2y minus y squared and x equals y squared minus 4y. So here 2y minus y squared is the blue curve. Why? Because it opens to the left and the coefficient of y squared is negative. And x equals y squared minus 4y is the green curve because the coefficient of y squared is positive and the green one opens to the right. So now we want to find the area restricted between these two curves. So first we find the intersection points, which is very easy to find. I'm skipping this point, but this is going to be 0, 0, and this is going to be negative 3 and 3. So if we want to set this with respect to x, we have to consider the vertical rectangle. So that means, so you see here, this rectangle is between these two branches of the green curve. And then up to here, we have this situation. So we have to solve the green curve. We have to isolate y for the green curve, which is very, very, very hard. It's not impossible, but it's very hard. And then you have to set another integral. And for the blue one minus the green one, again, you need to, for this step also, you need this, the green one and the blue one are solved with respect to y, with respect to x. That means y is isolated. And then the same here, like the rectangle is going to be, the vertical rectangles are between the branches of the blue curve. So what does it mean here? We need to set it into 3 integrals, and also we need to isolate y for each one of these equations, which is not easy. It's not impossible, but it's very hard. It's very, very hard. So I'm going to skip this one, but if we want to set this with respect to y, that's going to be very easy, because if you consider the horizontal rectangles, you see they are always, one side of them is on the green curve and the other side is on the blue curve, and then the horizontal rectangles, the y of them is moving between 0 to 3, up to 3, and it's because the equations are already given in terms of y. We don't need to do any extra step here. So the area is going to be the integral from 0 to 3, and then I have the right curve, which is the green one, and that's y squared. Sorry, the blue one, which is 2y minus, the blue one is the right one, which is 2y minus y squared, minus the one which is on the left, which is the green one. So basically we are thinking the left and right on the interval that we are integrating. That means you're not looking at this part and this part, you're looking on this part. So minus the other curve, which is y squared minus 4y dy. And this is a very, very easy integral to solve. Okay, so I stop here. Have a very nice day. And if you have any question, please come to my office hour on Ask or Ask in Piazza.